So today what we're going to talk about is, and this is what I enjoy, is talking about projects that actually happen and everything that it takes to make, in this case, a very large project, a very high profile project for the Kansas City, Missouri area. And it's called the Buccaneer Bridge project. And as Jennifer alluded to, we used many different technologies. We used aerial, we used mobile, we used SLAM, we used static or tripod scanning, and then obviously traditional surveying and everything else in between to get this job done. And I started with Trekk a couple of years ago. I took over for one of the original Regal owners that started mobile scanning. We met, and he was wanting to transition out, so I came over. I have 25 years of experience, a lot of it in Texas DOT, and I got into tripod scanning all over the world, laser tracking, and a number of things in mobile mapping and aerial. And at Trekk Design Group, which has been around for around 22 years, it's a woman-owned business. It's a little over 200 employees, I think approaching 250 actually today. We do everything from engineering to transportation to water systems to sewer type and civil design projects. That's us. We're looking good there. We get together. It's very, even though it's a larger company, they keep really small values. We have offices all over the Midwest, mainly out of Kansas City, St. Louis, Columbia, Springfield in Missouri, and then we have Omaha, Nebraska, Memphis, Tennessee, Little Rock, Bentonville, and some in Kansas. And so we work around those states that touch Missouri mainly. This is the project. This is where you're looking at the combination of the point cloud data, the extraction data, just to give an idea. The complexity of this job was around 4 miles of linear, but then when you add all the side information in, all the ramps, all the underneath, and how to collect it, there's actually a tunnel that's going to come up, as you're seeing at the top left of the screen. That's an old tunnel that went up through the side of the, we'll say, mountain cliff at the edge, and we had to make sure we all knew where that was. And as we started extraction, this was done in TopoDOT. That's one of the reasons we talk about it. There's many ways to get your data. I started out using Leica type scanners on toll roads, and we would use virtual surveyor and a number of other techniques, Trumbull scanners through their software to get it all. At the end of the day, most people that I've met so far have done a wide range of that in this room, and we as a company have settled on TopoDOT being our extraction tool because it's very repeatable, it's easy to learn. Last year we used about a little over 700 days of TopoDOT. We are not that big of a department. That really averages out with 260 work days a year, and if people take vacation, at 3 people were on TopoDOT every single work day last year, and we're on pace to go past that this year. We average about 30 projects in our LiDAR department per year, and that is a combination of tripod scanning, mobile scanning, aerial photogrammetry, and aerial LiDAR. So when you look at all these and try to combine all these data, the one thing you're going to know is you better know how to do control. And some projects, maybe we do sign projects as well. We don't put survey control out because nobody cares. We're not doing the DTM part of this, but this job was very complex and took several months. But the Buccaneer Bridge experiences about 950 crashes per year, which slows down an artery that goes from downtown just to the north side of Kansas City. And so with that being limited, they decided that, okay, we need to carry more vehicles as the population grows, and we need to cut that down. So the ideas were sent out, and Burns McDonald, HDMB, are all involved in the project. And on the right-hand side, they have the northbound is already up. and they're working on the southbound, and they've collapsed the other bridge or taken it down over time. This project is unique. It has a lot of people. It has the Missouri levee. There's railroad companies. There's the airport. That was a big deal when our flight, there's an airport directly on the other side, so we had to limit our height, time, and length that we could fly, and then the tunnel we talked about. And then you also have the boat traffic. But then this is where it comes together, right? So the first thing is if you're going to do construction, all the utilities that are out there. There are 25 different utility owners listed there for this project. And we got maps, we went out and verified, we potholed, people marked, we did all sorts of stuff to verify, especially in the critical boring areas where the new bridge was going to cross over. Then we actually had to go do stuff, right? So we went out there, we did traditional surveying, we used GPS, we used total stations, we ran levels, we made sure as we set the targets, and we did as the guys set up over there, he's over one of the targets for the driving and for the aerial, the combination. Those, we had to do the property boundaries, who owns what, is there stuff on their property, especially when it came to all those utilities, are all the leases, are they acquiring property, and all that. So even though today we're here just talking about the LiDAR portion, you know, you got to make sure you cover everybody else in the company. And as a professional and surveyor, even though I don't do that much, I make sure that we're covered on all of our bases. And at the end of the day, we're going to give somebody a pretty map, right? Some of the tools we have two different types of drones that we use. We have the DJI, and we have another one that's just for photogrammetry. We use the P1, the L1, the L2, and I should say when we talked about the 3 people that use TopoDOT every day, that's amongst 4 or 5 people, because some of our people are the people that fly and process that data, and we use several different types of software. We use TerraSolid, we're using Trouble Business Center, we're using various tools to get all of even our aerial into that. Then we have, like I said, one of the original our Regal systems. It's called the Robin system. You'll see in a minute that Robin system actually can convert to a backpack, and we can use it. And as we go around, obviously we're getting the images. Everybody that uses that, it's a fast way, keeps everybody out, especially on this project and many highway projects. Nobody's out there, and you need to make sure you know how to use your system, and your system is great for you. Don't let people tell you what's good or bad. You have to develop your own, and we did that, so I'll get on that soapbox a little bit. Having done LiDAR since 2005, there's a lot of wonderful systems, and I've used them. I've used many, Leica, Trimble, Regal, Topcon, everybody. And you have to develop an internal system of checks. Otherwise, it doesn't matter how pretty the data comes out, it might not be right. And one of the things I always say is the software is lying to you. So you got to have checks to make sure that what you did after you line, in these cases, maybe it's the photos or it's the flight lines, each path that you drove. As you line those up, the guys doing it know what it actually means. It's like GPS. If you don't know what the RMS value means, if you don't know what a geoid means, or things like that, then you really aren't grasping the whole thing, and you're getting data out, but it might not be the most successful thing you can do. So we also use a variety. We're not tied to one brand when it comes to data collection. We're agnostic. There's some of our clients like us to use our DJI and some of the software that comes from it, and some don't, for whatever reason. That's that. There's the right tool for the right job. We can go in, we can have a good discussion about the RTC 360. I wrote a thing a few years ago. I was big on static scanning on chemical plants, offshore refineries, offshore platforms, and went all over the world doing it. And we were using phase-based by ZNF and that. And when they came out with the 360, I thought Leica, their P-series is great. If you have it, to see the scan stations, the 3000s, they were all great. But there was a reason Leica bought the ZNF and put their case on it. And they got to a scanner that I thought really is a game changer because of some of the stuff it does. And I think it's really great for certain applications. We actually did recently do an entire mile of a road project just for the utilities, so the aerial lines, a mile long with the RTC 360 on a cart that I made, and we did that and we captured it in one day, and the street was 5 lanes wide, 4 lanes with a turn lane, and got all the power poles and everything in it. So you can use it. The only reason we didn't use the other one is we didn't have it available that day. We didn't have our mobile available that day. We didn't have our aerial available that day. We didn't have any of those crews available that day. But our big client, utility company, was like, no, we want you to today. Not tomorrow, not next week. So sometimes you have to adapt and overcome. And now I think that's where your system of coming down to how you get your data from whatever source is what matters. So once again, on this project, we used the SLAM system, and we took our Regal system off our truck, is what you see on the one guy, and then I threw NavViz in here. I think they have a good product because they have an inertial system. I don't sell for them. I don't care what you use, but I think the inertial system is a game-changing deal for SLAM because it helps keep the data aligned. And then we had to do hydrographic, and I did hydrographic up in Alaska. I worked for a big offshore company. We did it out the Gulf of Mexico, and on this project, we actually did single beam. That's all they cared about. We're doing multi-beam now. That's what you see on the bottom right. And then, of course, on the bottom left there is where you have to tie it in using GPS or whatever, or we could use our aerial imagery and 3D points for that. So, you know, in this particular project, we went through absolutely everything. And this is where the rubber meets the road, right? You have to have this plan, and everybody has to understand the plan, right? And at the top is the control. It was brought up earlier in the other talks. If you don't have the control, then you don't have a second check, right? Measure twice, cut once. So we took all these together, and through our own process, which some of it is just off the shelf, but knowing which keys to do and how to do it and trusting your people, which I do. I have 2 people here that I fully trust, and I don't even worry about data extraction or how we get the data together because as the market lead, I can't do the project, otherwise it's ineffective. So you need a good team, and I think everybody understands that, but you also need to get preferences out of the way. There's things I would do, but if we get the job done, the job's done right, you know, maybe, and I always use the thing, in AutoCAD, you could be the icon guy, or you could be the typing guy, right, on the commands. Doesn't matter which one does, they get the same thing done. So sometimes when you're looking at people, let them do their job and get out of the way. So we combine that, and this is where I believe we make a really good deliverable for our client, which is TopoDOT. And I didn't get paid to say that, but it's true. Because, like I said at the very beginning, we were using Leica and Virtual Surveyor, so it'd make it look like it just came out of a data collector, and we do the strings and all that. That is not as efficient, and we do use TBC some. And in our opinion, that's not as efficient as some of the things that you get out of here and what you're shown, right? So you got to vet everything, and you got to make sure you guys know how to use it and how all the machine learning and the AI learning, how that is done, and is it right? Don't just blindly believe stuff. Test it out, get it to work, and we use TopoDOT to make our microstation deliverables and sometimes convert it to AutoCAD and whatever. But quality control is where it's key. We do this on all the jobs. Maybe we flat photos and L1 or L2. We will compare the data which obviously is going to be a bigger data set. And you need to know why areas are not, and generally it's a bridge or something like that that's moving, and then the flight lines in between. So that's a 2-check system right there. So by the time we actually got here, this is like the 4th QA QC step that we've done. Whoops, back up. See, well, yeah, I'll figure it out once. I forgot it. Goes on. If you're not doing this, in my opinion, and in our opinion at Trekk Design, and all the DOTs and the civil projects we do, you should be using TopoDOT. And hopefully all of you have seen most of these features. I left this in there from a presentation I did with TopoDOT about it, because I think it is the rubber meeting the road. This is the things you need to do, you need to learn how to do to make your alls, no matter what size company you are, successful. And then the data you get, whether it be bridges, power lines, topo, understanding what the data means and how accurate it is and how you got it. It may take multiple sensors, and that's what this is. The one on the right came from our Trimble SX10. Top left came from a mobile, and the bottom left actually came from our aerial system. So the data sets get richer, and you may have to combine multiple data sets. So that's what I have for you, short, sweet, to the point. If you have questions about, if you're going to ask me specific about how to use TopoDOT, I'm going to have to defer to Phil and Alex. They know that. If you want to know how to do, combine multiple systems and things like that, and how to do that, I'd be happy to answer it, or if you have any other questions about this. That's what I have for you.
Anyone have any questions? Raise your hand. We'll come around the microphone.
What are your criteria for picking out, your different technologies for acquisition?
Okay, so that's a really good question, because we do test a lot of them. Everybody comes to us, right? And inherently, no offense to you guys or anybody else, I always say hardware and software salesmen lie, because they don't actually do a project at the end. They want to help you get there, they really do, but just because they can do it, and I worked with a programmer one time that he would write programs on one screen while we were doing laser scanning and made his own software, but nobody else could use it, right? You guys aren't that way, and neither is most vendors.
It's okay, you don't have to qualify at all. I got it.
Yeah, but what happens is you have to say, okay, I was a big Leica person, and I mean, really, that's all I wanted to use. And then I got into their Trimble and started using that, and I realized our guys could adapt to that workflow better coming from our GPS side, and they knew how to use the collectors and things like that. So, okay, maybe I need to change, and what can we collect in a fast amount? So we will get different sensors, and we will test them. And then we, like when we went with the DJI, we used our old system, we used that system, we compared it, and we said, okay, this is what we're doing. We actually got a new sensor for our deal, and we will test that. You have to test it. If you stop testing hardware and software, you will fall behind, 100% guaranteed. You can't keep going back, it's like the Cyclone guys. If you're just using Cyclone, you're not using Register 360, you're not using there are some tools in the program that you should use. Once you stop learning or using, there's a reason all software companies are updating their stuff. Sometimes I think they don't get enough feedback from the real world, because at the end of the day, you have to turn out a product, just like we do. And if you mess up your project and it's not right, and in our case, they're going to build a bridge, or they're going to build a road, or they're going to resurface the road, they're going to do whatever. That was a $230 million project. Nobody wants to go lawsuits over $230 million. So you need to have those QA/QCs that I said. You got to have your survey QA/QC, you got to have your LiDAR QA/QC, you got to have the QA/QC between them, and then when you extract the data, what's your QA/QC that you got everything extracted in the right way? Testing, that's the answer, testing.
I was curious how you combined the different forms of data. How did you tie in your mobile LiDAR with your maybe aerial LiDAR, and just how did you merge all the different formats?
Okay, so LAS is your key, right? So you need to process your stuff in whatever software that you're utilizing. Maybe you do. We use Agisoft and Metashape for our photos, and maybe we extract 3D points out of that. We use DJI Terra for our L2. We use Regal Software and TerraSolid for our mobile unit. We use TBC for our static unit, right? And at the end of the day, and then our SLAM has its own. And once we get that, that's where your control comes in, right? So each of them are controlled, and you got to believe in your control. So each of them are controlled out here in their own space. And then you combine the LAS, and then of course we showed you that we do heat maps, right? And once you combine those, that tells you. Now, sometimes you won't have a heat map. You're not going to have a heat map of the tunnel. You got to believe that the tunnel is where we said it is because of traditional surveying and the targeting or whatever you did to go through that tunnel. In my opinion, you should never, if you're trying to do survey grade, you should never do it uncontrolled. I know even with the NavViz and the SLAM and all that, we still put control and we still shoot them, and then we check it. We'll run it through their system, and then we pick the points out, and you could take it into a different program, which is what I prefer. I don't want to believe that the same system is always telling you. So we actually bring the points into MicroStation as well, and we can see that the same points that we use to align the point cloud in the mobile and the aerial are now in MicroStation saying they're still in the same place, right? So you got to do those. So. Anybody else?
I was just going to add to that.
We're down to our 5-minute warning.
Okay, 5-minute warning. Good. Yeah. So in that case, I think that's the value added that basically consultants bring, because, as Don's saying, you have to also be prepared that all these platforms are going to have different data characteristics. So your aerial may not be as accurate as your mobile, which probably wouldn't be, especially on the road. So when you combine these differences, and you need them all, you need a Navis maybe to walk under the bridge, or something like that. So this is that data fusion people used to talk about, but it's more complex than just throwing all the point clouds into one big data set. And the worst thing, you're always going to keep the provenance of each data, because sometimes you got to turn one off. I mean, you don't want UAV data over your mobile when your mobile is much more accurate. But you don't have to get the UAV more accurate if you're just doing corridor, and you can need a 10th out, beyond the road, and you need a couple hundredths, 500ths in the road, So it's all about maintaining that provenance all the time of your data, and it's the kind of thing not to beat up on TopoShare, but you always say, look, you keep the provenance, you keep each acquisition as a project, and you don't mess with that. You don't integrate it all into one big point cloud, because you actually start degrading the point cloud to the lowest accuracy in there. Because when you start extracting with TopoDOT, you'll start averaging in that.
Yeah, so you're right. I didn't say that. You don't combine it, all the LASs into an LAS, they have to know that they're loading aerial data, mobile data, static data inside the program, right? So just because we got it to an LAS that is in a format and in a size usable in there, they need to know that they're loading that type of data. So you know what the accuracy standards for that type of data is.
Yeah, you'll use that on different areas in there, something like that. So, and that's your value added. This isn't trivial stuff, and that's why I'm always against the big, oh, there's a truth model and everybody's going to go into this thing and get stuff out. No, it's not going to work. And Donna mentioned quality about 46 times. So, yeah, that's it. Okay.
Yeah. Thanks.
All right, guys. Thank you, Dan.
Thank you all.